LC circuits and energy. Suppose we charge a capacitor using a 4-volt battery. Then we insert the charged capacitor into a different circuit, namely the one shown in the figures below. Complete each figure by filling in appropriate integer potential values next to the capacitor plates and by circling the best choice for each energy to the right of each figure. Feel free also to make any additional markings on the figures that you feel are useful. We talked in an earlier video about an LC circuit and how what happens is charge sloshes in one direction and then it goes in the other direction and then it goes back and forth and back and forth. And so we're going to kind of see that take place here. Also in a previous video, we saw that the total energy is a combination of charge stored on capacitor plates and the current that is flowing through the circuit, namely through the inductor. When we start here, you can see we have charged up our capacitor with a 4-volt battery. So we might say that one plate is charged to 4 volts and the other one is charged to 0 volts. So maybe I want to put a couple of plus signs there and a couple of minus signs to kind of indicate that one side has a higher potential than the other. We hook that up. At that first instant, that inductor is going to fight the attempt of the capacitor to make charge go clockwise. So there's going to be an induced EMF in the inductor that points to the left here. You can see I've made the longer line on the left and the shorter line on the right to indicate that the inductor is trying to push this way. And there is no current that happens at that first instant. The amount of energy that's stored in this portion of the equation is all of it. All the energy is stored there, and since there's no current, there's no energy being stored in the inductor. Now, as time goes on, this capacitor will win out, and it will start to push charge through this inductor. There's going to be current going in that direction around this circuit. That potential, instead of being 4 volts on the left plate, now maybe it's 3 volts. It's less. And on this side, instead of being 0 volts, it is increased to, say, 1 volt. I'm just making up these numbers. The point here is there's now less charge on the capacitor. So I'll indicate those by using only 1 plus and 1 minus, which means that since the charge has dropped, we don't have 0 energy stored in that form, but we don't have a maximum either. We have that. And this current that's going through here is not 0, but it's not a maximum. So you can see that the energy is now distributed. Part of it is stored on the capacitor and part of it is stored in the inductor. Now, as time goes on, you can still see there is a clockwise push from the capacitor. And so what's going to happen is that current is going to continue to increase. I'll put maybe 2 arrow tails and maybe I'll draw I a little bit bigger this time. But the capacitor, pretty soon it's going to have essentially no voltage difference between its plates. Remember, this plate started out as 4, then it dropped to 3, now I'm dropping it to 2. This plate started at 0 and it increased to 1 and now it increased to 2. So now there is no energy stored in the electric field of the capacitor. And there is a maximum energy. This is the maximum current right there. When the capacitor is uncharged, the current through that inductor is a maximum. As soon as that happens, the capacitor isn't pushing anymore. So there's nothing really to continue pushing charge in the clockwise direction, but then the inductor says, wait a minute, now the current is going to start to drop off, and I don't like that. So it's going to release some of its energy to try to keep that current going. In the next bit of time, there's still going to be some current going in that direction, which means that there won't be a maximum or a minimum amount of energy stored from the current. And this plate then, since charge is still moving, again, I'm just making up numbers, but now this plate is going to end up with a higher potential and that one with a lower potential. there will be then some amount of energy stored in the capacitor as well. The inductor will do its best. It will basically expend all of its energy trying to keep this current going. And when all of its energy has been expended, there will be no current flowing, and this capacitor plate will have reached its highest potential, and this capacitor plate will have reached its lowest potential. So maybe I'll put a couple of plus signs there and a couple of minus signs there, like that. The maximum amount of energy will be stored on the capacitor, and we're not going to continue doing this, but what happens next, this whole process reverses.